What is up, Flutter devs? As we continue to port processing to Flutter, we know that we want to create some actual sketches, some actual demonstrations with processing, but we're still lacking some important tools to do that, one of them being input. We currently can't use the mouse and we can't use the keyboard, and today we're going to begin to change that. Today, we're going to get the keyboard working with processing, with Flutter processing, and then I think maybe in the next video, we'll figure out how to get the mouse working with Flutter processing, and then we'll have all of those input options to create interesting sketches and visual effects based on pressing keys, moving the mouse, etc. So let's jump over to the spec and see what we need to do in terms of the keyboard. Here we have the standard specification for processing, and you'll notice this header right here that says keyboard. Under keyboard, we have a number of different entries: key, key code, key pressed, key released, key typed. Let's quickly talk about what each of these is, and then we'll jump into trying to implement this. Key and key code are both local variables. This is key, and you'll see here in the example that in the middle of the draw call, we can ask, well, key press is another one we'll look at in a second, but we can access the key variable or property, and we can ask, is it lowercase b, is it uppercase b? Any letter on the keyboard, uppercase or lowercase, as well as a few other keys. Notice down here, backspace, tab, enter, return, escape, and delete. Those are all available in this key property. But then there's key code. There are other keys which are not ASCII keys that are reported in key code, such as up and down. I don't think that we're going to draw this distinction. I think the reason that two different properties are used in processing probably has something to do with how Java reports keyboard events. But in Flutter, we should be able to represent both key and key code with the logical key representation. You'll see that in code when we get there, but I don't think it's worth our effort to try to create enumerations or something for every single key on the keyboard and try to rediscover all of these possible values when Flutter has a decent representation for that already. So that's key and key code. And then there are three methods here, and there's one more property. Let's go look at the property first. Here is key pressed. You saw this before, but we'll show it here again. We can say if key pressed. When we go draw everything in our sketch, we can take different actions based on whether a key is currently pressed or not. Just a Boolean value that we can query when we paint. But then there are these three methods, these three callbacks: key pressed, key typed, key released. Here's key pressed. You'll notice that the developer who's creating the sketch can provide a callback, an implementation for key pressed, and this will be invoked when a key is pressed down. So when it's pressed down, key pressed is invoked. If you keep holding it down, then I think key typed will be run. So the key typed function is called once every time a key is pressed. Let's see, but action, control, and shift, alt are ignored. Because of how operating systems handle key repeats, holding down a key may cause multiple calls to key typed. So the question is, what exactly is the difference between key typed and key pressed? Let's go read here. Called once every time a key is pressed. The key that was pressed is stored in the key variable. Let's see. I'm not immediately seeing the difference here between the two. For non-ASCII keys, use the key code variable, fine. So it's unclear to me what the difference is. Like this ordering of the methods right here suggests that first key pressed is invoked, then key typed is invoked, then key released. Key released is the third function, and that one's obvious. When you release from the key, that's going to be called. Pressed is obvious, released is obvious. The question is, what is special about key typed? The only thing I can surmise based on this description is that maybe it's exactly like key pressed, except that certain keys like Control, Shift, and Alt do not trigger it. So maybe what it is that no matter what key on the keyboard you press down, key pressed is triggered. If that key is not a control key, then key typed is also invoked. And then regardless of what key you pressed, key released is invoked when you're done. Let's go with that assumption and see what we can do. Anyways, that's what we're implementing. Key, we're going to ignore key code. We're going to implement key pressed, the Boolean value. Then we're going to implement key pressed, key typed, and key released as callbacks. Let's see what we can do from a testing perspective in terms of categorizing our test. This is all under the input section. So it's input at the top level and then keyboard. So in our suite of tests, we will create a package called input. And then we will say keyboard test. And here we will define our test suite. We will create a group for input. We will create a group for keyboard. And let's import the testing package. And then the question is, what tests do we want? Well, when a key is pressed, there are a number of tests here. So the moment that a key is pressed, we want to make sure that that key is stored in the key variable. And we want to make sure that that key pressed was invoked and that key pressed is true. If it's not a control key, we want to make sure that key typed is invoked. If it is a control key, we want to make sure that key typed is not invoked. Then, perhaps maybe same test, maybe a different test. When we release that key, we need to make sure key released is invoked. Now, the definition of key, not only is it the key that's currently pressed, it holds the value of the key that was most recently pressed. So we need to make sure that sticks around as well. Now, this is going to be a widget test, but not a golden test. We don't care what's rendered. We just care about the interaction. We'll test widgets, and we will say, key press lifecycle. We're given a widget tester, and we'll make it async. And then let's just go grab another test, whatever we're pumping over here. So we'll take something like this. Import Flutter Processing. In draw, I'm not sure we care about that. Maybe we do, maybe we don't. Let's assume that in this test, we're going to test the entire life cycle of a key press. That means pressed. And I guess, we'll press it. If you hold down a key on the keyboard, the operating system will report the key over and over again. I'm not sure that widget tests do that, though. That may be a platform behavior. So for now, we will test the down part and we will test the up part, and we'll consider that to be complete. What that requires then is that there should be a callback. We should be able to pass in a callback for key pressed. And we should be able to offer a callback for key released. Those are two things that should exist that don't exist now. And at the end of this test, we're going to want to know how many times key pressed was invoked and how many times key released was invoked. That's how we want to make sure they're called, but we also want to make sure that they're only called once. If they're called 2 times, 3 times, 4 times, that means we have a bug. Now once we've pumped the sketch, we're going to need to add focus to the sketch, automatic focus, so that the keyboard sends its output or input, however you want to look at it, to the sketch. But that's something that's handled in implementation details. We assume that it automatically has focus. We assume that any key that we press should be picked up by that sketch. And we will use the tester to do this. We will say tester, and let's see what we have here in terms of keyboard keys. All right, we can send a key down event. That's what we want. And it's going to ask us for the logical key. Let's just say key A, not that it matters. And then, actually I just remembered, in draw, we probably want no loop so that we're not animating. And then I think we probably want to pump and settle here. We send the key event, and that we'll see in the implementation, that will probably directly invoke key pressed. But just to be sure that all of our behavior runs and shakes out, we go ahead and settle any functions, any execution that's queued up. We let it all go through, settle, and then we verify the results. And after that key down and settle, what we're going to expect a few things. We're going to expect that key pressed call count is equal to 1. We're going to expect that key release count is still 0. We're going to expect, we're missing one thing here, which is a logical keyboard key, that key better be the A key. And here's where these expectations come from. When key is pressed, we're going to take key pressed call count and we're going to add 1. And we're going to set key. So maybe this should, I guess we need to pass the sketch into these, because we want to say s.key, and then in key released, we say key pressed call count plus equals 1, and we will also update the key here as well. That's what leads to these expectations down here. Now let's see what this is complaining about. Okay, I think because we have null safety turned on, we need to make that nullable, and now the expectations compile. So once we've pressed the down key for A, we expect that the key pressed callback was invoked 1 time, the key released callback was not invoked at all, and the sketch is reporting key A as the key variable, as the key property. But then we're going to say tester send key up event, logical keyboard key, same key. Once again, we're going to pump and settle. And then we're going to take these expectations, and they're almost exactly the same, except now the released count should be 1. Okay? And I said before that even after the key is released, processing continues to report whatever the previous key was in the key property. That it's going to remain in that property, I guess, until a different key is pressed at some other time. Let's see if we can get this working, and then we'll worry about that key typed and the is key pressed. Actually, no, we should verify is key pressed here as well. Down here, when key pressed is invoked, we want to say is key pressed equals s.isKeyPressed. In processing, this Boolean value is just called key pressed. In Java, you can get away with, I guess, having the same name used for a property and a method, but in Dart, we can't. We can't have key pressed the method and key pressed the property. They're going to be seen as the same thing. We're going to rename that property to is key pressed. And then we're going to update that in key released. In this, let's see, in this first set of expectations, we're going to say is key pressed should be true. And down here, we're going to say is key pressed should be false. All right, now let's go see how we're going to make this happen. Here's our processing widget, and then we want to go down to sketch. Sketch.simple. We know that we need to take in those two callbacks. Void function sketch key pressed. Void function sketch key released. And we will need local references to those functions. Those don't exist yet, so we will create them. We'll create those local private references here. Fix the typo. Okay, we're now taking them in, but they're not being used anywhere. Let's quickly take a look at how setup and draw work. There's doSetup, which is a private method, and let's go find out where that's invoked. In the sketch painter down here at the bottom of the file, that's where doSetup and onDraw is invoked. So the strategy here is that there are private methods that are only visible to other parts of our Flutter processing implementation, so that those private methods are invoked at the appropriate time, but no one else is allowed to invoke them. And then inside of those private methods, like doSetup, eventually the public or the sketch version of setup is called. Similar for onDraw, there is draw. Let's repeat that same pattern for these new methods. Where would be a good place for that? I guess we'll just come in right below draw. First, the private version. On key pressed. And then there's going to be a public version, which is key pressed. Now, when key pressed is executed, this is, again, so this version key pressed is what you, the sketch developer, the person who's using processing, writing your sketch, this is what you would override, just like draw up here. What we're going to say here is key pressed the variable dot call this. Key press underscore key pressed is the callback that was passed into our simple constructor. We also want on key released, and then there's a public version, which is key released, where we will say key released call this. Sorry, key released. Now, what do we do in these private methods? Well, at some point in there, we need to go ahead and call key pressed in that one. And down here, we need to call key released. But key pressed also should probably set the current key and is key pressed. So somewhere in here should be is key pressed, and that's true. Actually, let me take that back. We don't want this to be, we want this to be private. We want the sketch to be able to query is key pressed, but we don't want the sketch to be able to set is key pressed. And therefore we need a private variable, and we'll see how we deal with that shortly. We also need to set the current pressed key. And how do we do that? What should the value be? Well, this indicates that we would like for this private method to receive that information. We'll take in a logical keyboard key called key, and we'll set it like that. Similarly, in onKey released, actually, let's go back to the guide for this. So here's a question. When we press the key down, we update the key property. When we release the key, should we again update the key property? If there's just one key being pressed, it doesn't make any difference. But what if you press A and then B and then release A? What should the value of key be? Press A, the value's A. Press B, the value is B. Release A. Should the value be A or should the value be B? Let's go see what's stated about key released. The key released function is called once every time a key is released. The key that was released will be stored in the key variable. So we do update it in key released. So key released also needs to know which keyboard key was released. And then we set key equal to key and is key pressed equal to false. Although this one's also a little tricky. What if there is another key that's pressed? Maybe is key pressed needs to work a bit differently. The Boolean system variable key pressed is true if any key is pressed and false if no keys are pressed. I think what we can do here, so we could either handle this inside of the sketch or inside of the processing widget. We will handle this inside of the sketch. When a key is pressed down, we will take a pressed key set and we will add to it the key that was pressed. This is us keeping track of every key that was pressed. When the key is released, we will say pressed keys dot remove key. And then is key pressed will be equal to pressed keys dot, I don't know if it's size or length. Size is greater than 0. We'll see once we define it. But this way, even when the key is no longer pressed, if there are other keys that are still pressed, we want is key pressed to remain true. And that's what this condition gives us. Now, all these red squigglies are because we haven't actually defined these properties yet. So let's go define these properties, get these compilation errors to go away, and then see where we're going to call these private methods. And at some point, I guess I really do need to clean all this stuff up. If anyone's wondering why I'm defining all of this functionality in one file for right now, it's because we still don't know where the most important relationships are. Like when we get into bitmap manipulation, I don't know what needs to talk to what. And so it's tempting to break this stuff up now, but it's really too soon to break it up. Now let me place this section in order here. So input comes after shape, I guess. Shape and then input. Here's shape. This is still shape attributes. I'm going to copy that header. And let's see, where is transform? Is transform in there too? Okay. So after shape attributes, we will start input keyboard. And for input keyboard, we said that we are going to have a logical keyboard key called key. Now, I mentioned before that we want to be able to query it publicly. We just don't want to be able to set it, which means that we want a public getter method that returns that value. Similarly, for is key pressed, that's how we handle that. And then I said that we wanted a set of keys. We want a set of logical keyboard keys called pressed keys, and initially there is nothing inside of it. Let's see, what else did we have? I guess that's it. Up here, so this size value is not correct. Apparently it's length. Okay, that's fine. So here's what's going to happen. The widget, once we implement it, the processing widget is going to invoke onKeyPressed with the given key. We're going to add it to the set of keys that are pressed. We're going to update the currently pressed key, and we're going to say that there is at least one key that's pressed. Then we're going to invoke the public version or the sketch version of key pressed. And maybe it does nothing, or maybe it does something. It's up to you, the developer who's using this. Then when the key is released, we're going to receive the key that was released. We're going to remove it from our set of pressed keys. We're going to update the current value of key to the one that's no longer pressed, the one that's released. And then we're going to update is key pressed based on the total number of pressed keys. And then we're going to invoke the public version of key released. Now, real quick, let's go back to the test. Notice that everything here in the test compiles. I didn't say it worked, but it compiles. And so now would be a good time to watch a test fail. So we're down here, we're in input. Let me open the terminal here. We will say Flutter test input keyboard test, and let's see where this fails. And maybe there's still an animation going on somewhere. Let's see. Nope. Okay, I don't know why it took so long, but it looks like it hit a legitimate failure. Expected 1, actual 0. So key pressed call count, we expected 1, but the actual was 0. So we failed on the very first expectation, which is where we expected to fail currently. That's fine. Let's come back here to core. And the reason it's failing is because onKey released and onKey pressed are never called. So let's go up to our widget. The widget, now we're back in Flutter territory here. And the question is, how does our widget recognize when keys are pressed? I mentioned that one thing that we need is a focus node. Whatever widget currently has focus, I believe, is the widget that handles the key. I believe that the raw keyboard listener is going to need a focus node. So we will take in a focus node. Now, it's not required. You typically don't want to require a focus node because many times the rest of your app doesn't care about that thing having focus or controlling the focus. Sometimes you do. But let me show you what to do when you take in anything like this that's optional but necessary. So I say optional but necessary. We do need a focus node, but the focus node does not have to come from outside our widget. We can create it inside our widget. This is also very similar to things like sometimes animation controllers, scroll controllers, text editing controllers. You can pass one in if you want to, but even if you don't, one is created internally on your behalf, and that's what we're going to do here. Here's how we deal with that. In our state object, we're going to have a focus node. That thing is going to exist. It's going to exist late, but it will exist. And here in init state, we're going to say focus node is equal to, well, if we are given a focus node, that's the one we want to use. But if we're not given a focus node, then we want to create our own. You're going to see me implement three things: one in init state, one in did update widget, one in dispose. And this pattern is the same or similar, again, for focus nodes, all sorts of controllers, anything that you definitely need to have, but may not have been passed into your widget. Then there's did update widget. Maybe we were given a focus node and then it was taken away, or maybe we were not given a focus node and then we are given one later in the widget. So we have to handle both of those situations. Here's how we do that. If widget.focusNode is not equal to old widget.focusNode, we only care if there's a change. If we go from null to a focus node, if we go from focus node to null, or if we go from focus node 1 to focus node 2. Those are the permutations that we care about. If it's the exact same focus node, then everything is fine. But in this case, we're saying, what if they're not the same? Then what do we do? Well, first, we will take, we know because the focus node has changed, we are going to have to reconfigure our focus node. There's no way around that. We are going to have to reconfigure our focus node. The first thing we're going to do is take our focus node. Actually, I'm getting ahead of myself. I'm thinking about if we already had a listener on it. Okay, I won't do what I was about to do, but we do need to still do something here. Our underscore focus node inside of our state object needs to respect whatever the widget is currently configured with. So we will set our focus node. It'll be the same thing we did in init state. Either we want our local focus node to be the same one that's in the widget. So if the widget has a focus node, that's the one we want to use. Otherwise, we will need to go ahead and create one. So the situation we're looking at here is that either the old one is null and the new one is non-null. The old one is non-null, but the new one is null. Or this is focus node version 1 and this is focus node version 2. Either way, we need to update our local state reference to the latest widget version of the focus node, or if it's not provided, if it's null, we still need one, so we have to create one. There's often you will add listeners to things, and if we had a listener on the focus node, we'd need to add and remove the listener here, which is what I was thinking about. But I don't think that we need to add a listener to the focus node, so we're fine. Down here in dispose, you may be tempted to say focus node.dispose. That is not a complete solution here. You should only dispose of objects that you created. If we created the focus node, then yes, we should dispose of it. But if it was given to us, we should not dispose of it, because whoever gave it to us might use it for something else. How do we figure this out? Well, if widget.focusNode is null, if the widget doesn't have a focus node, then we must have created our own, in which case we can dispose of it. But if the widget does have a focus node, we do not want to dispose of it. It's not ours. We didn't create it. We don't own it. We should not dispose of it. This is an important thing to get right in your widgets, especially if you are building packages. If you're building things that other developers use, you need to respect these kinds of nuances. Now, we have a focus node. What are we going to do with it? Here's our build method. We have this center with a custom paint, and down here we have our sketch painter. We will surround the entire visual area with a raw keyboard listener. It doesn't necessarily need to be around the whole visual area because it's based on the focus node. you'll see if I put the cursor over it, it says, hey, we need a focus node. Where's the focus node? The focus node is what determines whether or not this keyboard listener receives key events. We could go down and just wrap the custom paint, but I think it makes more sense that this non-visual logical thing wrap all the visual stuff. And by the way, we are implementing keyboard input, so we can remove that from our to-do. Now, this alone doesn't solve anything for us. Yes, it will receive keyboard input, but it doesn't do anything with that input. We need onKey. And so we will define a local method called onKey to deal with this. I guess we can just come put that right here, onKey. And what is it going to get? I believe it's going to get a raw key event. Now, notice that there's only one callback here, regardless of what's happening with the keyboard. So whether we're pressing down or up or anything else, it's just this one method. And if we look at what's in the event, we can ask certain things like, is shift or control pressed, stuff like that. We can even ask if a specific key is pressed, but we don't actually know what this event represents. And that's because the type of event is represented by the type of the object, like this. If raw key event, if event is, and then there are multiple types of raw key events. Here's a down event. Else, if event is raw key up event, it is released. That's how you tell the events apart. So now we're getting a lot closer, right? We can now do something when pressed and we can do something when released. Well, what do we want to do? We want to get our sketch. Want to get our sketch and we want to say on key pressed, and we're going to pass in event.logicalKey. And down here, when it's released, we're going to say widget.sketch.onKey released event.logicalKey. Let's save that. So now we have this raw keyboard listener widget, which when a key is intercepted by it, calls onKey, and then we invoke it on our sketch. Now, for this focus node, I guess we'll see in our, I don't know if this focus node is going to receive focus automatically, and if it doesn't, we might not receive any key presses. Let me put a print statement here. So regardless of whether our test passes or fails, let's see if this print statement comes out. Let's come down here and let's run our test again. Okay, it failed, and I'm not seeing that print statement. So for now, actually, I guess maybe in our test we can handle this. Let's create a focus node. And I don't know if we can request focus just sitting out here in the middle of nowhere or not, but I don't know. Let's see. Maybe that'll blow up. Maybe it won't. We'll come into processing and we'll say focus node. We'll pass in our focus node. We'll save that. Let's run this. All right, notice key press received. But interestingly, it's run twice. So the point is, first we need to request focus. If we don't have focus, and that's the whole point of the focus system, only one thing gets input from the keyboard. If we don't request focus, we don't have focus, we don't receive the keys. We got past that problem by passing in a focus node with focus. But now the question is, why is this being called twice? Well, first, let's say event runtime type, and then key. Let's see what exactly is being reported to us twice. All right, so we have a down event, but then it's immediately followed by an up event. Actually, I guess that was expected because we came down here and we said send key up event. Let's comment out the second half of this test. Let's see if we get through the first half of the test. Okay, and we did. So we get through the first set of expectations. Key pressed call count is 1. Is key pressed is true. The key is A. The key released count is 0. All of that is correct. So we've made a lot of progress here. We are handling some keyboard stuff. Then we send the key up event and we pump and settle. Now the problem here, let's see where exactly it said it failed. Key pressed is 2 instead of 1. And that's because I screwed up the test itself. This is not what we should be incrementing. And so I'm sure some of you were screaming at your monitor when you saw me type that, huh? You probably knew it the whole time and it's driving you crazy, and it took us until now to find it. Okay, well now it's found. So now let's run this thing again. Hey, our test passes. So all this stuff that we wrote initially, we said this is how we want it to work, and now it does work this way. I'm going to come back in here and remove this print statement. We still have one more test to write, I guess. We still have one more piece of functionality that's not represented here. And I'm thinking about whether it's better to add that to this test or a separate test. The other thing that we haven't implemented yet, to be clear, is key typed. And honestly, I should probably run this. Let me open up processing. Just waiting on processing to start here. Okay, here's processing, the real thing. Let's copy this code directly as it exists here, paste it in there. Let's play. Okay, here's the sketch, and I'll press A. So I hold down A, and we are getting both key pressed and key typed. Let me hold down Control. It says it only says pressed. So when I hold down Control, we get key pressed, but we don't get key typed. Let me hold down an arrow key. Arrow key, we get pressed, but not typed. Option, same thing. So Command, Option, Control, and arrow keys, none of those cause key typed. Let's see, did I try Shift? There's Shift. How about Caps Lock? Caps Lock, Tab. Well, Tab is recognized as a character, I guess. The question is, how do we differentiate between these? We could literally have some kind of massive if statement, or we could have a set of all the keys that are recognized. And maybe that's what we have to do. Oops, I pressed escape and it killed the sketch. Although interestingly, escape triggered the typed callback. But there's just there's so many keys on the keyboard to worry about. Now you might think, well, we could just report all the letters and numbers. So instead of creating a set of all of the non-character keys, we could just create a set of all the character keys. That's tempting, but then there's also all of the symbols. So all the symbols that are part of your numbers, all the symbols on the right side of the characters, those are all character keys as well. Also, other languages have other characters that are not on my keyboard. So I don't know what the right answer is here. I think let's just do some spot implementations. Let's do the obvious keys, and then if other people want to contribute more keys to this set later, we can consider taking it. So what we're looking at here is that when we have the raw key down event, we always want to call on key pressed, but then we essentially want to say, in our case, if not is control key, then widget.sketch.onKey typed event.logical key. And then we have to figure out how to decide what is a control key and what is not. Well, let's come up here to the top and let's say we'll create a final control keys, which is going to be a set of logical keyboard keys. And we will say keyboard key, control, keyboard key. Meta is the name for command or control. Command on Mac, control on Windows, that is called meta. Alt, is option one of them or no? No. And then shift. Let's see, is caps in here? Caps lock. Escape, arrow left, arrow right, arrow up, arrow down. I assume, well, I guess we can test this out. I assume that delete and backspace are considered character keys because they impact text content. Yep, that was delete. Oh, that was backspace, and here's delete. So both backspace and delete are considered kind of regular keys. What else do we have here? Function keys, that's doing other stuff. End. So end is considered a control key. Page down is considered a control key. I don't know if those keys are going to have logical key representations. Let's see. Home, okay, I guess home is there. End, okay. Those were some of the keys that I was just pressing. How about page up and page down? Yep. Okay. Well, I think that's probably sufficient for now. This is our custom aggregation of what we're considering to be control keys. And then down here, we will say if control keys contains event.logical key. So if not contains, so if the given key is not a control key, we're going to invoke onKey typed. But we never implemented anything related to onKey typed, so we need to do that now. We'll come down to the definition of sketch.simple. We're going to repeat the same process here. Instead of key pressed, we'll call it key typed. And then down here, we'll say key typed equals key typed. We will declare it here, key typed. And then we'll come down here to where these methods are defined, we will copy key pressed and adjust it. On key typed, and then key typed, key typed, key typed. We don't need to update any of this other accounting because that's already done in onKeyPressed, and onKeyPressed is always invoked. Now in this case, we did not start with a test. We probably should have, but we didn't. But now we will go write the test to confirm what we've seen here. So let's copy this test. We'll make it a separate test. We will say key typed invoked for non-control key. We don't care about the release being called. We don't care about is key pressed. We don't care about assigning the key. We do, and actually we don't even care about key pressed being called. We care about key typed call count, and that's all. So key typed call count, get rid of that other stuff. Then we send a key down event. Now this test again was invoked for a non-control key. So key A is a non-control key. It's a character key. What we want to know is key typed call count should be exactly 1. And that's our whole test. But we also need essentially the converse test, which is key typed not invoked for control key. Almost all of it's going to be the same, except instead of key A, we're going to pass literally control, and then we should never receive a call. With that, let's run the entire test suite, and if all tests pass, then I think we're good to go. All right, something did not go right. Key typed not invoked for control, key expected 0, actual 1. All right, so it seems like we're still being invoked even when control is being pressed. Let's see, key typed. All right, let's come back here to our widget. Come back up here to our widget where we're making this decision. And just to be clear, let's say print pressed key. What is that key? Event logical key. This is a control key. Excuse me, this is not a control key. I mean, I did put control in there, right? Yeah, it was the first one. I'm wondering if the problem here has to do with left versus right. Let's add left and right versions for these different keys. I think those are the only ones that have left and right sides. Let's see if the test passes now. Sure does. +3. That was the problem. Okay. Good enough of a solution as far as I'm concerned. Let me get rid of these print statements and then I'll run the test again. And now we shouldn't have any print statements. It should just be passing tests. Okay, all tests passed. Great. Now let's do a recap of what it is that we did here. Start at the Flutter level and then go down to the processing level. We introduced a raw keyboard listener widget, which requires a focus node. Focus node is what sends or organizes input to a given widget within your tree. Assuming that focus node has focus, the on-key callback will be invoked for any and every key that is pressed or released on the keyboard. That then invokes our on-key method here. If we are dealing with a key down event, we invoke on-key pressed inside of our Flutter Processing sketch. If the key that's pressed is not a control key, then we also invoke on-key typed. If the event is a key up event instead of a key down event, then we invoke on-key released. Going down, leaving the widget territory into sketch territory, we took our simple constructor and we added key pressed, key typed, and key released. These are all callbacks that you can now pass in to a simple sketch constructor. They follow the same dynamics as setup and draw. Down here, we have this private method on key pressed. This can only be invoked from within this file. So we've hidden it from the rest of the world. But when it's invoked, we update some local accounting. We hold a record of the key that was just pressed. We set the local key property and we set is key pressed to true. Then we call the public version of key pressed. Now the public version will, it will either forward the call on to the callback that was passed into the simple constructor, or if you're implementing a sketch by literally implementing sketch, you will put whatever code you want inside of this call right here. Which reminds me, no, I take that back. I was wondering if we have to pass the sketch in. We don't, because if you are a sketch, then you literally are a sketch. You don't need it. On key typed, same thing. The private method is invoked from our widget, which then forwards on to the public version that you can override. On key released, private version. Private version, which removes the key that was released from our set of pressed keys, sets the current key to the key that was just released, updates is key pressed based on the remaining other keys that are pressed. Then invokes the public version, which you can override right here. So that is our implementation of everything keyboard related. You can see that we have everything here except for key code, because in the case of Flutter, we have logical keyboard key, which you can ask a logical keyboard key. Hold on. I know you can ask the key event if shift and control is pressed, but maybe you actually have to ask the logical key what it is. Let's see. Okay, so the logical key really is just part of an enumeration, but the event itself, you could say, is meta pressed, is shift pressed, is control pressed. But it looks like processing is set up to kind of force you to track multiple key presses. We're not going to reinvent processing. So again, back here to the API, we have everything here except for key code, which I think we can avoid. If you have a use case that requires key code, just file an issue and explain why you need it and why key is not enough. And then we have key pressed for us is called is key pressed. And then we have the key pressed callback, the key typed callback, the key released callback. So there is keyboard input. That is our first input that we support for Flutter processing. And I think probably in the next video, we'll tackle some or all of this mouse behavior, and that will kind of give us full input to processing, and then we can maybe apply that in some kind of coding challenge in the near future. All right, well, that's it. And with that, I'll see you in the next video.